In this lesson, we will be working with radicals. We're going to learn how to simplify radicals, multiply, divide, add, and subtract radical expressions, but we're going to save rationalizing the denominator for the next lesson. So what really is a radical? A radical is essentially an expression that has a root in it. So these are all examples of radicals. This is also an example of a radical. Now you might have been more familiar with square roots. For instance, the square root of 4, and we know that's actually equal to 2. Because what that means is we're looking for two numbers that multiply by itself to give us 4, and that's 2. So we know this to be the square root. There's really an imaginary 2 here, but we don't have to write that 2. So whenever we see that root symbol, it's automatically the square root of whatever is underneath. But sometimes there is another number right here. This number is known as the index. So here we have 3 as our index, and we're looking for the third root of 27. So that means a number multiplied by itself 3 times is going to be equal to 27. And since 3 times 3 times 3 is equal to 27, the third root of 27 is equal to 3. Here are two types of radicals. So we have an entire radical, and that's when you have your radical, but there's an imaginary 1 in front. So it has a coefficient of 1. And then we also have a mixed radical. So this is when the coefficient is anything but 1. So there's a number here, and this coefficient here is 3. And this really just means 3 is multiplied by root 5. Before we begin simplifying our radicals, we need to learn some of our laws of radicals, and we have the multiplication rule and our division rule. So the multiplication rule states that when we have an entire radical, whatever is underneath that root symbol, so if we have a number or term, you can take the factors of that number and rewrite this entire radical as the root of one factor multiplied by the root of its other factor. So for example, we have the square root of 24, and 24 has different factors, for instance, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So we can take two factors of 24. So for instance, two factors are 4 and 6. We can rewrite that using those two factors. So the square root of 24 is just equivalent to writing the square root of 4 multiplied by the square root of 6. So let's do some examples before we move on to the division rule. We're going to simplify the square root of 75. That doesn't mean to put it in your calculators and evaluate it. We need to write this in simplest form. And before we actually start simplifying this, I want you to become familiar with your perfect squares. Any number times itself is a perfect square. So these are all of your perfect squares, or at least the ones that we'll need to know for now. So perfect squares are very important because if we use a perfect squares as one of our factors, then we can rewrite that as a whole number. So for instance, if we used 4, the square root of 4 is just equal to 2. So to simplify the square root of 75, we want to look for two factors of 75, but specifically, you want to find out if there's a factor of 75 that is a perfect square. And 25 is in fact a perfect square and a factor of 75. So the square root of 75 is equal to the square root of 25 times 3. And if we rewrote that with each factor as their own square root, it's just the square root of 25 times the square root of 3. So we can simplify this square root of 25 because the square root of 25 is essentially just 5. So our answer is 5 times root 3, and we cannot simplify that root 3 anymore. So this is in fact our simplified version, and that is our final answer. So we're going to simplify the square root of 24, but we're going to look for factors of 24 that are perfect squares. 1 is a factor of 24, but it's not going to allow us to break this down any further. 4 is definitely a factor of 24, And looking at our other perfect squares, these are not factors of 24, so we are going to use 4 as one of the factors. So the square root of 24 is equal to the square root of 4 times the square root of 6. And if we rewrote that with individual radicals, so it's the square root of 4 multiplied by the square root of 6. Now we can definitely simplify that square root of 4 into 2, so it's just going to be 2 times the square root of 6, and that is its simplest form. You can try these next examples on your own if you're ready, otherwise just continue watching. So this just means 5 times the root of 27, and we want to simplify this radical here. So we're going to leave the 5 there on the outside. And if we're looking for factors of 27, we want a factor that is a perfect square. So 27 does have 9 and 3 as factors. So that is just 5 times the square root of 9 times 3. And we can rewrite that radical as two separate radicals. So 5 times the square root of 9 multiplied by the square root of 3. So we can change that square root 9 into 3. So it's just going to become 5 times 3 times the square root of 3. And we can multiply these two whole numbers together. So if we actually multiply 5 times 3, we're just going to get 15 times the square root of 3. And we can't break down the square root of 3 any further, so we are done. Our next example is the square root of 22. Now thinking about our factors of 22, we have 1 and 22, we have 2 and 11, and those are actually all the factors of 22. None of those factors are perfect squares, so we can't actually simplify this any further. So this is done. So our next examples requires us to convert these radicals into entire radicals. And remember that an entire radical just has that root symbol with a number underneath, where the coefficient is a 1. So our first example is 4 root 5. This is a mixed radical, so we have a coefficient of 4, and we want to rewrite this so that it's an entire radical. So we want to make some changes here so that these are both underneath the radical symbol. So square root of 5 is already underneath the radical symbol. We need to change this 4. So we want to find out something that's equivalent to 4 where we can put that square root symbol. And we know that 4 times 4 is equal to 16, and vice versa. The square root of 16 is equal to 4. So we can actually change that 4, rewrite it as the square root of 16, and that's just going to be multiplied by the square root of 5 because we're not changing that square root of 5. And using the multiplication rule, this is really just the square root of 16 times 5. And if we actually just do that multiplication, 16 times 5 is 80, so this is really equivalent to the square root of 80. So in our next example, 3 root 10, we have root 10, which we want to keep, but we want to change this 3. And we know that 3 is equal to the square root of 9, so we can replace that 3 with the square root of 9. So we're going to write the square root of 9 multiplied by the square root of 10. And using our multiplication rule, that's just the square root of 9 times 10, which is the square root of 90. So our next example is negative 6 root 3, and we want to change that negative 6. But we can't actually write anything that has a negative 6 equal to the square root of something because the square root of any number will not be a negative number. So we're actually going to get rid of that negative. We do know that the square root of 36 is equal to 6, so we can actually rewrite this with the negative on the outside, and then the square root of 36 is multiplied by the square root of 3. So let's rewrite that all under one radical sign, 36 times 3, and that's just going to be the negative root of 108. So we have 2 questions here that involve multiplication. You can try them on your own or just continue watching. So the first one is the square root of 2 multiplied by the square root of 10, and of course this is just the multiplication rule. So that is really just the square root of 2 times 10, which is just the square root of 20. But we're not done here because the question says to simplify the following radicals. So is the square root of 20 in simplest form? It's not. If you think about the factors of 20, are any of those factors perfect squares? Well, 4 is definitely a perfect square. So if we wrote this using its factors, it would be the square root of 4 times 5. And then when we separate that, it's the square root of 4 multiplied by the square root of 5. And the square root of 4 is really just 2. So our answer is 2 root 5. In the next question, we have negative 2 root 5 multiplied by 3 root 10, okay? And that really just says negative 2 times root 5 times 3 times root 10. So looking at this, we have some common items here that we can multiply together. So we can multiply these whole numbers together, and then we can also combine this root 5 with this root 10. Okay, so negative 2 times 3 is just negative 6, and root 5 times root 10 is the square root of 5 times 10. Okay, and that's just going to be negative 6 square root of 50. So that could actually be simplified even further. Looking at this square root of 50, if we think about factors of 50, well, 25 is a factor of 50, and 25 is a perfect square. So this would just become negative 6 and square root of 25 times 2, which is equivalent to negative 6 times the square root of 25 times the square root of 2. And that square root of 25 is really 5. So we got negative 6 multiplied by 5 multiplied by the square root of 2, and we can multiply those two numbers here. So negative 6 times negative 5 is just negative 30. And we cannot simplify that square root of 2, so this is now our final answer, negative 30 root 2. So here's our next question. We have brackets here, and we have two things that are being added inside the brackets, but outside of the brackets we have this 2 root 2. So we need to distribute. Remember our distributive property? We got to multiply that 2 root 2 by everything that's on the inside of those brackets. And once we actually do that multiplication, so we are going to get 2 multiplied by the square root of 2 times 7, and then we're going to add, so these whole numbers can be multiplied together, so that's going to become 6, and root 2 multiplied by root 3 is just the square root of 2 times 3. So if we simplify that, that's going to be 2 root 14 plus 6 root 6. Now we need to check if these can be simplified even further. So there are no factors of 14 that are perfect squares, so we can't actually simplify that any further. And there are no factors of 6 that are perfect squares, so that can also not be factored or simplified any further. And now we need to do the addition. But can we add these two things together? Can we add 2 root 14 with 6 root 6? We actually cannot. The thing with adding radicals is that underneath the square root, that number needs to be the same. So we treat them like variables. And since these are not similar, they're not the same number, we cannot add them. Okay, so this would be our final answer. And just to give you an idea of adding radicals, if we had 2 root 6 plus 6 root 6, see how underneath our square root there is a 6. 6 is common, so we can add these. And when we add them, we're adding our numbers in the front. We're adding our coefficients just like when we're adding and combining like terms and like variables. So this would just become 8 root 6. So that number underneath the variable doesn't change, and we're just adding the coefficients together. So here's our next question. We have two terms multiplied by another two terms, and we're going to need to use our distributive property, but more specifically, we're going to use FOIL, okay? So we're going to multiply the first two terms together, then our outside terms, then our inside terms, and then our last terms. So remember, when we are multiplying, we're multiplying our whole numbers together and then our radicals together using our multiplication rule. So 3 times 2 is just going to be 6. Then we're going to do 3 times 3, which is 9. And then we're going to leave that root 24 as is. Next, we have negative 2 times 2, which is just negative 4, and we're going to keep that root 6 as is. And then here we have negative 2 times 3, so that's going to be negative 6. And root 6 times root 24 is just the square root of 144. And before actually doing the addition and subtraction, we want to check if we can reduce any of these, okay? So 6 we're going to leave as is because we can't change that yet. But 9 root 24, so the square root of 24 can be simplified because 4 is a factor of 24. So this is just going to become 9 and the square root of 4 times 6, okay? This minus 4 root 6 cannot be changed because root 6 cannot be simplified any further, so we're going to keep that the same. And this root 6 times root 144, well, the square root of 144 is actually just 12. So this is really just negative 6 and times 12. Okay, so let's keep working with this. We can't do anything with that 6 yet, so we're going to keep it. And we're going to keep this plus 9, but the square root of 4 here is just 2, so we're going to change that to 2. And we're going to keep the square root of 6 because we can't simplify that any further. And we're going to keep this minus 4 root 6 because we can't change anything with that. But negative 6 times 12 is just 72, or negative 72, so we can change that. And if we keep going, 6 is going to stay the same. This 9 multiplied by 2 here, we can multiply those whole numbers, and that's just going to be 18 root 6. This minus 4 root 6 we're not going to change, and then we're also not going to change this minus 72. Now looking at this, we can't simplify any of our terms any further, but we can start adding and subtracting. So we have two whole numbers here that we can combine together. Okay, so 6 minus 72 is actually just a negative 66. And then looking at our radicals here, we have 18 root 6 minus 4 root 6. So we do have a common radical here. We have a root 6 that's common. So we can actually combine these two together. So remember, when we're adding or subtracting radicals, we're going to take the coefficients and add those two coefficients together. So 18 minus 4 is 14. So this is going to be plus 14. And we're keeping this the same, the square root of 6 the same. So our final answer is negative 66 plus 14 root 6. So those were all our multiplication questions, and then we're going to go back and look at our division rule. The division rule just says that if we have a radical and underneath that root symbol we have a fraction, then that's just going to be equal to the root of our numerator divided by the root of our denominator. As an example, we have the square root of 24. So what number divided by another number will equal 24? So 48 divided by 2 is equal to 24. So this is the same thing. The square root of 48 divided by 2 is the same thing as the square root of 24. And we can actually rewrite this as the square root of 48 divided by the square root of 2. So let's apply that division rule that we just learned. We have the square root of 33 divided by the square root of 3. And using that division rule, this is the exact same thing as the square root of 33 divided by 3. And 33 divided by 3 is just 11. So our answer here is the square root of 11. So our next question is an entire radical. We have the square root of 3 divided by 16. So I'm actually going to separate these into two separate roots. So using our division rule, this is the same thing as the square root of 3 divided by the square root of 16. Okay, and the square root of 3, we can't do anything with that, but the square root of 16, we can actually solve that because 16 is a perfect square. So the square root of 16 is just 4. So our answer here is the square root of 3 over 4. So here's our next question. We have 12 root 75 divided by 4 root 3. And we have these whole numbers here that we could just divide. So 12 divided by 4 is just 3. And we're actually going to combine this root 75 divided by root 3 into one radical. So this is the same thing as root 75 divided by 3, okay? So I'm going to keep that 3 on the outside and do the division of 75 divided by 3. So 75 divided by 3 is just 25. So this is the square root of 25. And the square root of 25 is conveniently just 5. So this is going to be 3 times 5. Okay, which is just 15. 15 is our final answer, and we are done. So let's try another question. We have 6 minus the square root of 45, all divided by 3. This is the same thing as 6 divided by 3 minus the square root of 45 divided by 3. So I'm going to rewrite that. So this 6 divided by 3, that's actually just 2. And the square root of 45 over 3, well, I can't just reduce that right away, but the square root of 45, I can use its factors of 45, to rewrite that using our multiplication rule. Okay, so some factors of 45 are 9 and 5. So I'm going to rewrite that as minus the square root of 9 times 5, and that's going to be all over 3. And I chose those particular factors because we can change that square root of 9 because the square root of 9 is really just 3. So if I rewrote that, square root of 9 is just 3. And the square root of 5 we're just going to keep as is, okay? So this is just going to be over 3. So looking at this, we have negative 3 over 3, and negative 3 divided by 3 is just negative 1. So we can reduce that. Those cancel each other out. So this is really just 2 minus the square root of 5. And we cannot subtract these or simplify it any further, so it looks like we are done. Here's the next question, and I definitely want you to pause this video and try it on your own, and just come back to the video to check your answer. Welcome back, and here's the answer. So I'm going to go through this. I worked on this similar to our last question, but there are different ways to approach this question, but you should have the same final answer. So I broke this up into two fractions. I did 10 divided by 2 minus the square root of 32 divided by 2. And 10 over 2 is just 5. And then I broke up this square root of 32 into the square root of 16 times 2 because the square root of 16 is just 4. So that broke down nicely. So we have 5 minus the square root, 5 minus 4, root 2 over 2. And this negative 4 over 2 can be reduced into negative 2. So our final answer came out to 5 minus 2 root 2. So we are down to our final examples. In this one, we have 4 root 3 plus 2 root 3 minus root 3. And remember, when adding and subtracting radicals, you need this thing, our number under our root sign, to be the same. Treat them like variables. And if they are alike, then that means you can combine them. So since these are all root 3, we can do that addition and subtraction all together. So we're going to look at our coefficients. So we got 4, 2, and then we got this imaginary 1 here, okay? So 4 plus 2 minus 1 is equal to 5, so our answer is 5 root 3, and that root 3 stays the same. So down to this next one, we do have some that are alike. So these have root 5, and then our other ones have a root 7, so we can combine those like ones, okay? So 8 root 5 minus 4 root 5 is equal to 4 root 5. And negative 3 root 7 plus 7 root 7 is just plus 4 root 7. So that is our final answer. And we've made it to the last question. So looking at these radicals, none of them are the same, so we can't even add or subtract these. But these are higher numbers. We can definitely find factors and try to simplify each radical separately, okay? So 12, we're looking at 12. Our factors of 12 are 4 and 3. So this would just become 7 times the square root of 4 times 3. Plus, so 18, if we break that down, that can be broken down to the square root of 9 times 2, okay, and 27 can also be broken down. So 9 is a factor of 27, and that's going to be broken down into the square root of 9 times 3, and 50 is broken down into the square root of 25 times 2. So I found a perfect square in all these factors here, so I could definitely break this down even more. So this square root of 4 turns into 2, so we're going to have 7 times 2 times the square root of 3 plus that square root of 9 is equal to 3, so we got plus 3, and we're keeping that square root of 2. Then we got minus another square root of 9, so we'll change that into 3 times the square root of 3 plus, and that square root of 25 turns into 5, keeping that square root of 2, okay? So at the beginning here we have 7 times 2, so we got to actually multiply those together. So 7 times 2 is just 14, and we're keeping that square root of 3. And can we simplify anything further? This 3 root 2 will stay the same, minus 3 root 3 plus 5 root 2. So that all stays the same, okay? And if you look at this, we do have some of the same radicals here, some of the same radicands here. So we have root 3's, and then we also got root 2's that we can combine together, okay? So 14 root 3 minus 3 root 3 is just equal to 11 root 3. And then we got 3 root 2 plus 5 root 2. That is equal to 8 root 2. Okay, and we can't simplify anything any further, so we are done.